Hey friends, this is Quiescent Current speaking.
Thanks for the nice introduction. Today we're going to take a look at internal cable resistances and how they matter with the fact how fast your phone or other device can charge from a wall outlet or other USB supply. So first we need to take a look at how internal cable resistances actually matter with how your phone can charge and with what current your phone can charge. To know about that, we have to know about this USB-A to USB-C cable, where the maximum allowable voltage on this end is 5.25 volts and the minimum voltage that your phone needs to see to be able to be within USB spec is 4.75 volts. This means that no matter what current your phone is actually drawing through the cable, the maximum allowable voltage drop across this cable is going to be 0.5 volts. So for example, if your phone wants to draw 1 amp of current through this connector and your supply is going to supply 5.25 volts, the maximum internal resistance of this cable can be calculated by R equals U over I, or I equals U over R, depending on the way you want to see it. So what you actually want to do is, if you charge with 1 amp and you know that you have 0.5 volts of allowable voltage drop, then you can divide it out to 500 milliohms or 0.5 ohm maximum resistance of the cable, including both connector resistances. And so now that we know that, we have to know about how we can actually measure that. For this, I've soldered 2 wires onto this A to C cable queue, with which we can apply a constant current to the cable through the VBus or VCC line and the ground connection, so you measure through the whole cable until this connection, then short it together and then measure it back. So this is the absolute voltage that your device is going to be able to see in a realistic use case. So first, let's bring in the multimeters. This multimeter on the right hand side here, the red one, is going to be used to measure the current. Right now it should display almost 0, yes, exactly 0. And the one on the left hand side, which is going to beep in a second, is going to measure the, thanks for beeping, is going to measure the voltage across the cable while we are supplying a constant current through it. So let's shove that out of the way and bring in the cable and cable tester. First, I'm going to connect the first multimeter that is going to measure the voltage across the cable, like this. And then secondly, I'm going to connect the constant current source that we are going to use to apply a constant current, which we're going to measure with the multimeter on the right hand side, like this. So I'm going to turn on the power supply, which you're going to be able to hear because its fan starts spinning up immediately. So what you can see here is that our voltage actually is set to 2 volts, and that's why it's saying that it's overflowing. So we're going to set it to a larger voltage range. So we have pretty much exactly 2 volts on the spot in idle current or no current situation. So let's first start with this really expensive cable, the red one. I got a while ago because I wanted to be able to charge my phone quite quickly with it. If we're going to connect it like this, you can see that the moment we connected it, 1 amp started to flow on the spot, and we have a voltage drop of 0.25 volts. This means that at the current of 1 amp, we would get 5 volts on the spot if our supply would supply 5.25 volts, or 4.75 volts if we were to draw 2 amps from it, which is the maximum rated current this cable can do. Which means this is a really high-end cable, and if we try to apply more than 2 amps of current, the supply is still going to do it and the phone is still going to receive it. So you can look at that. Now we have almost 2 amps, and if we go up to 2.4 amps, the voltage drop is already 0.6 volts, which would mean that we are out of USB spec. So let's go back to our 1 amp current load and connect a different cable to it to see the difference of a good to a bad cable. For this, I'm going to bring in the cable I've just shown you, the black one, And I'm going to untangle it like this and connect it to this A to C cable queue. Like this. What you can see, at 1 amp of current, we already have the 0.6 volts of voltage drop. This means that this cable is not even capable of handling a 1 amp current. And if we divide this 0.6 volts over the 1 amp, we know that the internal resistance of the cable, including the two connectors on the left and right hand side, is 0.62 ohms or 624 milliohms, which is far out of spec if we want to draw anything reasonable. So to get in a calculator, we can now calculate the maximum permissible current any device can draw if it wants to have 4.75 volts and stay within the USB spec, which means that we have an allowable voltage drop of 0.5 volts. If you can see that here, yes, you can, perfect. And we have a total cable resistance of 0.62 ohms or 620 milliohms. Now we see that the maximum current we can draw with this cable is approximately 0.8 amps. So with this cable you can charge your phone, but it is definitely going to take a while. To show you an even more extreme case, I have brought out this really long cable that I got a while ago from eBay, and it originally has got a USB-A to micro USB connector like this, you can see, but I've generally been using it with this adapter to supply USB-C devices with it. And if we again do the same thing we just did and connect it to this modified tester, we see that at the 1 amp of current already 1.5 volts are dropping across this cable. This means if you have, for example, a 5 volt power supply or 5.25 volts power supply, which we have most of the time, the voltage on the other end is only going to be 3.75 volts, which means at 1 amp of current you're not even going to be able to charge a lithium cell with it or any other cell that needs a lot of voltage or a reasonable voltage. So if we do the same thing we just did and divide the 1.53 volts over the 1 amp, we know that the cable has an internal resistance of 1.53 ohms. And if we want to calculate out the maximum permissible current this cable can handle, we again divide the 0.5 volts that we have as a maximum permissible voltage drop with over our 1.54 ohms, and we now know that this cable can only supply 0.32 amps or 320 milliamps. So this means that my phone, for example, has an internal battery capacitance of 3000 milliamp hours and we can supply 300 milliamps. This means that my phone is going to take at least 10 hours to fully charge its battery, if not more, if it's going to reduce the current at the end of the charge. If we want to take a more extreme example, this is a power bank I got a while ago and features a 10,000 milliamp hour internal cell. If we divide the 10,000 milliamp hours over the 300 milliamps, we will find out that it takes ages to fully charge this power bank. And with ages, I mean it's going to take 33.3 hours. So that's now why you know that you should always invest in a bit of a higher and pricier cable if you want to make sure that your devices charge quickly enough so that you don't have to wait a day or two. If you have any questions, just put them in the comments and let me know. Thanks.